All right, so this quiz will be over trigonometry. And let's say you have a right triangle labeled as A, B, C. So we have a right triangle ABC, and this right here is your angle of reference. So to label this triangle, well, we say across from angle C, this is our opposite side. Across from the 90-degree angle, this is the hypotenuse. And then lastly, this side here, this is the adjacent side. So do not forget SOHCAHTOA. So the S stands for sine, so sine of C is equal to the opposite side, so O for opposite, over the H, or hypotenuse. Then we have CA, which is cosine of C, is equal to, not opposite, but adjacent over hypotenuse. So A for adjacent, H for hypotenuse. And then lastly, we have TOA, which is T for tangent. So tangent of C is equal to opposite over adjacent. So let's go ahead and do some practice problems. And we're going to do this. So I have a right triangle. With vertices A, B, C. And the length of AC is 20, so the hypotenuse is 20. The length of AB is 12, and the length of CB is 16. So we're going to go ahead and express each ratio as a fraction. And that's all I want you to do. I want you to express each ratio as a simplified fraction. Okay, so express each ratio as a simplified fraction. I want you to find sine of A. So A is the angle of reference. Here's A, so I'm going to label this triangle based on where A is. So across from A, this is the opposite side. Across from the 90-degree angle, this is the hypotenuse. And then A is next to this side. And then we already, or I should say that, we already have opposite. We already have hypotenuse. So this must be the adjacent side. So sine of A, S for sine, it means opposite over hypotenuse. So what's the opposite side over the hypotenuse? Well, that is 16 over 20. But we want to make sure that this answer here is simplified. So what goes into 16 and 20 at the same time? That would be 4. Or you can use your calculator and input 16 divided by 20. Press math, enter, enter. And you will get your simplified fraction, right? So that's just going to be 4 over 5. So sine of A, based on this problem here, is 4 over 5. And make sure that you're reading the directions. It says express each ratio as a simplified fraction, and you're just going to do it based on that, okay? Let's do some more. Let's find cosine of A. Cosine of A. So here's A, cosine, C for cosine, adjacent over hypotenuse. So the adjacent side is 12. And the hypotenuse is 20. So then I'm going to use my calculator. 12 divided by 20. Math, enter, enter. You get 3/5. All right, so let's move on to tangent of A. Tangent of A, T for tangent, so it's opposite over adjacent. So the opposite side is 16, and the adjacent side is 12. So 16 divided by 12, math, enter, enter. Your answer is 4/3. All right, so that's pretty simple. Let me go ahead and throw in one more problem. Let's say find cosine of C. So the angle of reference changed. We went from A to C. So that means we need to relabel this right triangle. So let me draw this triangle out. Here's A, here's B, here's C. This is 20, this is 12, and this is 16. So here's C. So now this is the opposite side. This is the hypotenuse, and this is the adjacent side. And then C for cosine is adjacent over hypotenuse. Don't forget, right? SOHCAHTOA if you're not remembering these ratios. So please, please, please do that on your paper. You are allowed to do that. So cosine of C is the adjacent side over the hypotenuse. So it's 16 over 20, which is 4/5. Okay? So that's basically how you express each ratio as a simplified fraction. Okay, so we're going to go ahead and do more examples. So let's transition over to this. So let me write this question down. Use a special right triangle to express each trigonometric ratio as a simplified fraction and that's basically it. So remember we have our 45, 45, and 90 triangle. So this triangle is isosceles. So we have a root 2. And then the other one is our 30, 60, 90 triangle. So let's label this 30 here, 60. So this would be a root 3, and 2a. So we're not going to use special right triangles or solve using special right triangles, I should say. We're going to use trig, right? So let's say I want you to find sine of 45. So which triangle has a 45-degree angle? It would be this one, right? And we have two 45, so which one do I pick? It doesn't really matter, just pick one. And then use trigonometry. So this is my angle of reference, right? So this is going to be my opposite side. This is going to be the hypotenuse. And then this right here is the adjacent side. So sine of 45, what is sine? Well, remember to always write SOHCAHTOA on your paper. So it's S for sine. We're going to be using the opposite over the hypotenuse. So opposite over hypotenuse. So that's A divided by a root 2. And then I can go ahead and cancel the two a's here. So that's 1 divided by root 2. But remember, we're going to express each trig ratio as a simplified fraction. So you can't have that radical in the denominator. You're going to have to rationalize the bottom and the top by the square root of 2. So since we're multiplying two fractions, we multiply across. So it's 1 times the square root of 2, which is just root 2. And the square root of 2 times the square root of 2 is the square root of 4, or you say it's 2. So sine of 45 is root 2 over 2. So it's really important that you rationalize the denominator so you get this answer, okay? All right, we're going to go ahead and move on to, let's do cosine of 30. So cosine of 30. This triangle has that 30-degree angle, so I can go ahead and label based on where the angle of reference is. So this is the opposite side. This is the hypotenuse. This is the adjacent side. So cosine of 30, C for cosine, adjacent over hypotenuse, right? So adjacent is a root 3, and the hypotenuse is 2a. Notice that we have a up top, a down below. I can go ahead and cancel the 2a's, so that's just going to give me root 3 over 2. And 2 isn't a radical, so I don't need to rationalize at all. We have that square root of 3 up top. That's good. It's already simplified. I can't break down that 3 at all. So this ratio here, that cosine of 30, which is equal to square root of 3 over 2, is good. So I don't really need to do anything there. All right. What else do we have? Let's try tangent of 45. So tangent of 45, we're using this triangle. So tangent, T for tangent, it's opposite over adjacent. So I have A divided by A. I have both A's, one up top, one down below. It's kind of like saying 5 divided by 5, right? So that's just going to be 1. Tangent of 45 is 1. All right, so let's switch gears. Let's try cosine of 60. So that means we use cosine of 30. 30 was the angle of reference for this triangle. Since 60 is the angle of reference now, I need to relabel this 30, 60, 90 triangle. So what do we have? 30, 60, 90, a root 3, 2a. So this is the angle of reference. So this is the opposite side. This is still the hypotenuse. And this is the adjacent side. So cosine is adjacent over hypotenuse. So a over 2a, that's just going to be 1/2. Very, very simple. So a over 2a, the adjacent side over the hypotenuse, that's just going to become 1/2 once I simplify it. All right, so I want to see if there's anything else I could do. Maybe I could try tangent of, let's see, tangent of 60. Let's do that real quick and see what happens. So tangent of 60, that's opposite over adjacent, so that's a root 3 over a. So then the 2 a's will cancel out, so that's going to give me root 3. Okay, so let's try cosine of 30. Oh, sorry, not cosine of 30. Cosine of... No. Let's try sine of 60. So that's a root 3 divided by 2. A root 3 divided by 2a. Both a's cancel out, so I have root 3 over 2. And then let's try sine of 30. Sine of 30. So we're going to use this triangle here. So sine of 30, that's just going to be opposite over hypotenuse. So a divided by 2a. That's just going to be 1/2. Let's try tangent of 30. Tangent of 30. So that's opposite over adjacent. So what do we have? A divided by a root 3. So a divided by a root 3. The 2 a's cancel, so I have 1 over root 3. You can't have a radical in the denominator, so you need to multiply the bottom and the top by root 3. Then we multiply across, so it's going to be the square root of 3 over 3. Okay? So there you go. We just did a lot of these problems involving special right triangles, but we use trigonometry, right? So there you go when it comes to those examples. All right, so the next thing that I want to do is, let's say I give you a right triangle. We're going to label this A, B, C, and the measure of AC is X. The measure of AB is 11, and the measure of angle C is 21 degrees. So what we're going to do is we're going to find the value of X, and we're going to round to the nearest tenth. So what we're doing here is we're trying to find this missing side, and we're going to be using trigonometry to solve for that missing side. All right, so the only angle that I see besides the 90-degree angle is the 21 degrees. So this right here is going to be the angle of reference. I'm going to use that to label this figure here. So across from 21 degrees, this is the opposite side, and then this is the adjacent side, and then right here is the hypotenuse. So then I can go ahead and figure out, based on the information that I have here, I can see that X is the hypotenuse and 11 is the opposite side, or I should say that the opposite side, the length of that is 11, and the length of AC, which is our hypotenuse, is X, right? So I'm going to write SOHCAHTOA. And again, we have the opposite side and the hypotenuse. That means we're going to be using sine, right? We're going to be using sine. So sine of your angle, which is 21 degrees, is equal to the opposite side over the hypotenuse. Now, notice that X is in the denominator. So what we're doing right now, if you're confused, is we're solving for X, right? It says find X right here on our paper. X is in the denominator. So what I can do is I can swap the sine of 21 and X. So it looks like this. X equals 11 over sine of 21. So now, you're not done yet. We need an answer where we need to round if we need to. So I'm going to pull up the calculator real quick. Include the memory so I can demonstrate what you're supposed to do with your calculator. The first thing that you need to do is make sure your calculator mode is in degree. So you're going to press the mode button. Scroll all the way down. See how it's highlighting radian right now? We want to make sure that we highlight degree instead. So you're going to go ahead and arrow to the right and be sure to press enter. If you don't, then it's just going to be stuck in radians, which we don't want. So how do we exit? We're going to press second mode, and then we're going to figure out what X is. X is equal to some number. We're going to round to the nearest tenth if we need to. So 11, right? We're going to input 11 divided by sine of 21. So here's the sine button. Press 21, and then there you go. We have this, but we're going to round to the nearest tenth, right? So 30.7. So that's your answer, 30.7. All right, so let's do another example. We just did this. We're done. We're going to go ahead and do this right here. So we have triangle JKL. This is 49 degrees, and that's our right angle. The measure of JK is 33, and the measure of KL is L. This is our angle of reference. So here's opposite, here's hypotenuse, here's our adjacent side. So then SOHCAHTOA, right? So we have the opposite. Oh, I'm sorry, I made a mistake here. The measure of KL is not L, it's actually X. There you go, that's X. All right, so we're going to go ahead and find X. So opposite over adjacent. So tangent of 49 is equal to 33 over X. Notice that x is down below, so we can go ahead and swap. All right, so here we go, 33 divided by tangent of 42. So that is approximately 36.6. All right. All right, let's see this example here. So here we go. So this is z, y, x. That's angle x. The length of zy is x. The measure of angle z is 34 degrees, and the measure of zx is 28 degrees. So this is our angle of reference. So this is the opposite side. That's the hypotenuse. And that's our adjacent side. So SOHCAHTOA. I have adjacent, hypotenuse. I'm using cosine. So cosine of 34 is equal to x over 28. And that's perfect. This is exactly what I want to show. To get x by itself, I need to get rid of the 28, right? So I need to multiply both sides by 28. So 28 times cosine of 34 is x. So then I'm going to input 28 cosine of 34. So that is going to give me approximately 23.2. So there you go. All right. Let me go ahead and transition to this. Use a calculator to find the measure of angle T to the nearest degree. So we're going to find the measure of angle T. Anytime we find an angle, so we need to use inverse trig. We need to use inverse trig whenever we need to find a missing angle. And it says to round to the nearest degree, which means we're rounding to the nearest whole number. So round to the nearest whole number. So suppose you have triangle SRT. And this triangle is a right triangle. And the measure of SR is 8, and the measure of ST is 12. We're finding the measure of angle T. T is going to be our angle of reference, right? So this is the opposite side, this is the adjacent side, and this is the hypotenuse. So writing SOHCAHTOA on our paper, it's T for, I'm just kidding. I got that mixed up. You know what I just said. We have opposite over adjacent. So that means we are using T to figure out what the measure of angle T is, right? And I'm supposed to write tangent of T. There you go. So write tangent of T is equal to 8 over 12, right? This is the opposite side over the adjacent. Then I need to apply inverse trig, right? So I need to do the inverse tangent here. So I'm going to write T equals tan minus 1. This is the work that I want to see on your paper. So T is equal to tan minus 1 of 8 over 12. So then let's use our calculator here to figure out what the measure of angle T is. So I need to press second, tangent, and then input 8 divided by 12. So then our measure of angle T is 34 degrees. All right, let's do one more example. Let's say you have a right triangle that looks like this. And this is S T R, and RS is 25, and RT is 30. So then we're looking for the measure of angle T. So this is the opposite side, and this is the hypotenuse, and that's our adjacent side, right? So opposite over hypotenuse. So that's sine. So sine of T equals 25 over 30. So T equals sine minus 1. So inverse sine of 25 over 30. So what is the measure of angle T? Here's my calculator. So I'll write second sine. So I have inverse sine of 25 over 30. So this is going to be 56 degrees. And that is your answer.